Now let's see this question. This is given in GATE 2014. Consider the following schedule S of transactions T1, T2, T3, T4, and these transactions are given like this, and the schedule is given like this. Now the options are like here. Check these options. Which of the following statement is correct? So in the options they are asking schedule S is conflict serializable but not recoverable. Schedule S is not conflict serializable but is recoverable. Schedule S is both conflict serializable and recoverable. Schedule S is neither conflict serializable nor recoverable. So they are mainly asking about conflict serializable or not and recoverable or not. Now let's see this schedule. I'll just show you how to do this. Now let's talk about recoverable or not. So when will we say that a schedule is not recoverable? If a transaction is reading data which is written by other transaction, and if this transaction commits before the other transaction, then it is going to be not recoverable. So what I mean to say is, let us say a transaction is writing some data like this and some other transaction is reading from it, okay, and it is committing before this one gets committed. Now if this happens, then we can say that this is not recoverable, right? Now but if you look at this, let's see who is writing and who is reading from them, then we can understand it, okay? Now if you see this, x value is being written here, right, and who is reading from this write? From this write means it should be below this, right? Now this is not reading from this, so you should think about who is reading from this write. So if you look at this, reading is here, isn't it? Or even here also there is a write, okay, there is a write here, and again there is a overwrite, right? So anyway this has to be considered. Now from this, who is reading? Here it is, there is a read. Now if you observe this, before this one gets committed, this one got committed already, therefore there is no problem with this write read. Now let's see any other write reads are there. Now there is one more read here, it is reading, and who has written this y has been written here, right? And now this is getting committed late and this got committed earlier, therefore there is no problem here. So again it is recoverable. And again any other reads, here there is one more read, right, and who is writing to it? No one is writing to it, no problem. And again there is one more read, who is writing to this? No one is writing to this, right? So it is directly reading from the database, right, reading from the database, so you need not worry about it. So whenever you are reading data from some other transaction, you should be sure that other transaction commits, then only you should commit. If that is the case, then it is recoverable. So in this case it is recoverable, right? In fact, we are reading or writing only from the committed data. So you see this here, write is done, immediately commit is done, write is done, immediately commit is done, write is done, immediately commit is done. Therefore after every write we are committing immediately, therefore there is no way we are going to get any problem coming to cascadeless also. So it is cascadeless actually, and every cascadeless is already recoverable. Alright, so it is definitely recoverable, we need not worry about cascading. Now let's see whether the schedule is conflict serializable or not. For that reason, let me write the graph T1, T2, T3, T4, precedence graph representing each transaction in a node. Now let's see all the conflicting actions. So this one is the first action, so it is conflicting with this. What is it saying? T2 then T3, therefore T2 then T3, right? And again this is a conflicting action. What is it saying? T2 then T1, so T2 then T1, right? And that is it. I think there is no conflict here, there is no conflict here, done. So this one is done, and the next one is this one, right? Now let's see what is it conflicting below it. Now there is a conflict here, right? Now what is it saying? T3 then T1, therefore T3 then T1, right? Yeah, and again no conflict. Yes, there is a conflict here. Now what is this conflict saying? T3 then T4, T3 then T4, right? And this one is done. Now let's talk about this. So is there any conflict with this? No conflict, but there is a conflict here, right? What is this conflict saying? T1 then T4, so T1 then T4, right? Just try to see if there is any cycle in this at every point whenever you add something, right? So as of now there is no cycle, till now there is no cycle, so let's keep moving. So this one is done, right? Over. Okay, and now this one, write y and read y is there, so there is a conflict here. What is this conflict saying? T2 then T4, so T2 then T4, no cycle as of now. And again this one is done, so let's talk about this Z. There is no conflict anywhere, okay, and there is no conflict with these two. So this is the entire graph. Now in this graph we don't see any cycle, therefore it is definitely conflict serializable. So the schedule is conflict serializable as well as recoverable, okay.